Okay, guys, coming back to finish the test. We were on question 13. Okay, so it's a double angle formula. So 2 cosine squared is equal to cosine of 2 theta. So that means this is equal to cosine times 2 times 17 pi over 12, which is the same thing as 17 pi over 6. So right here, you put in cosine of 17 pi over 6. And then we got to find out what that is. So 17 pi over 6. Sorry, guys, I'm going to go kind of fast because my birthday party to go to, honestly. 17 over 6. So let's see, 12, 18 would be there. So 17 pi over 6 is in quadrant 2. So cosine is negative. So it's negative pi over 6. Next to it is square root of 3 over 2. So negative square root of 3 over 2. Move this okay. Okay, this is a adding formula. So tangent of alpha plus beta is tangent of alpha plus beta over 1 minus. So this one looks right. Yes. So then we got to actually find out what those things are. So number 14. I'm looking for tangent of 7 pi over 3. 7 pi over 3 would be in quadrant 1. So basically, tangent of pi over 3 is equal to tangent of pi over 3, which is, I'm going to go back over here. Tangent is opposite over adjacent, so that's square root of 3. So everywhere I see a tangent of pi over 7 pi over 3, I'm going to put pi over 3. And then 7 pi over 4 is right here. All students take calculus, so tangent is negative. And tangent of pi over 4 is 1. So everywhere I see that, I'm going to put a negative 1. So tangent of pi over 3 is square root of 3 plus negative 1 over 1 minus square root of 3 times negative 1. So that's what I'm going to fill in the blanks. And it looks like it's D, goes with my signs. So right here, square root of 3. Right here, a negative 1. Right here, a square root of 3. And right here, a negative 1. And I think that's it. Oh, and then they actually want us to find out what it equals. Okay, so let me do the math real quick. So this is square root of 3 minus 1 over 1 plus square root of 3. So that's what goes down here. Square root of 3 minus 1 over at the bottom, there's a 1 plus square root of 3. All right, see if I can squeeze number 15 down here. Oh, I didn't complete all parts. No. Oh, you just clicked on the wrong one, sorry. Yeah, okay, now we're good. Okay. This one is a good one to work. I'm going to make a space. Let's do 15 right here. Okay, square root of 2 is equal to sine of 2 theta minus 1 equals 0. So that means sine of 2 theta is equal to 1 over square root of 2. So I know that it is a pi over 4 angle. So basically 2 theta is a pi over 4 family, but it's where sine is positive. So that's here at pi over 4 and here at 3 pi over 4. So we've got two equations, but we're going to have to solve them. So 2 theta is equal to pi over 4 plus my period, 2 pi k. And 2 theta is equal to 3 pi over 4 plus my period, 2 pi k. But we have to divide everything by 2 for both of these. So this is going to be theta equals pi over 8 plus pi k. And theta equals 3 pi over 8 plus pi k. Now you just have to check, because if I can get 3 pi over 8 with this equation, I don't need a second one. So adding a pi would be 8 over 8. So pi over 8 plus 8 pi over 8 is 9 pi over 8. So I can't get this one from here. So I have to use the two equations. That goes in for this first part. So I'm going to go ahead and type that in. So this is pi over 8 and pi k, and then 3 pi over 8 and pi k. Okay, so now we got to do our answers. For sure, we got pi over 8, and we just can't go above 2 pi k. That's where it ends. So 2 of 8 would be 16. So I already did it once. So I have 9 pi over 8. 9 plus 8 is 17, which is over 2. So we won't use the next one. Then we have 3 pi over 8. And then 3 pi over 8 plus 8 over 8 is 11 pi over 8. So the other one is 11 pi over 8. And if I added 8 again, I would be over 2. So these are my 4 answers. So pi over 8, 9 pi over 8, 3 pi over 8, pi over 8. Now the ones we did like this earlier were easier because it just had a theta, not a 2 theta. So when it just has a theta, it's usually just 2 answers down here. But when we made it smaller by dividing by 2, it gave me actually 4 answers. So when you're solving for theta, either when you have a 2 theta or maybe theta divided by 2, that's when you'll have more answers. If it's just a theta, you'll probably just have 2 answers down here. Hope that kind of makes sense. Okay, so this is a double, or one of our formulas. So it looks like cosine and cosine plus sine and sine is cosine minus alpha minus beta. So cosine of alpha minus beta would be this one. So pi over 12 minus, this would be, let me write that for you, minus a negative becomes positive, right? So it'd be 2 pi over 12, which is the same thing as pi over 6. So right here, I know that it's going to be a, and it's cosine of pi over 6. Right? So what is cosine of pi over 6? Using our perfect triangles, cosine is adjacent, which is square root of 3 over 2. So right here, you put in square root of 3 divided by 2. Oh, it wasn't too bad. Okay, number 17. I have negative cosine theta plus 1 is equal to 2 sine squared theta. Well, it's one of the solving ones, but I need them to be the same trig function. So I'm going to rewrite sine as, remember, our Pythagorean identity is sine plus cosine equals 1. So 1 minus cosine squared is equal to sine. So I'm just going to rewrite it like that. Then you can distribute the 2. And then I'm going to move everything to one side. So I'm going to come over here, and this is going to be a positive 2 cosine squared theta minus cosine theta. And then 1 minus 2 is negative 1 is equal to 0. So remember, my cosine theta is equal to x. So 2x squared minus x minus 1 equals 0. So I've got negative 2 and negative 1, two things that multiply to give me negative 2 but add to give me negative 1, or negative 2 and 1. So I've got to come back and divide by 2. So here, and just to save time, our answers are opposite of these. So here we've got cosine theta equals, this equals negative 1, so it equals positive 1. And then cosine theta equals negative 1/2. Well, we can use the 1. If it was any other number, we can use it, but cosine does equal 1. So where does cosine equal 1? Cosine is the same thing as x. So where does x equal 1? Right here. That's at 0, the angle 0. So this is theta equals 0. So one answer from there. Where does cosine equal 1/2? Well, that's, if you look back up here, a pi over 3 angle. But it's negative, so cosine is negative here. So, and here. So the pi over 3 angle is 2 pi over 3, and then 4 pi over 3 right here. So that's the two answers from here. 2 pi over 3, 4 pi over 3. So we actually have 3 answers. So the answers are 0, 2 pi over 3, and 4 pi over 3. All right, number 18. Use the sine of 2 angles to find. Okay, so what can I add to get 13 pi over 12? So sine of 13 pi over 12. So you need 2 numbers that you can add to get 13 so that they would be alpha and beta. So eight, maybe. No. I'm trying to do things that would simplify. So what about 10 and 3? Let's see if that works. 10 pi over 12 plus 3 pi over 12. This would simplify to be 5 pi over 6 plus pi over 4. Yeah, we can use those two. So this is my alpha plus beta. So sine of alpha plus beta is the same thing as sine of alpha cosine of beta plus, sorry, this thing's in my way, so I'm gonna move it and I'll move it back. Cosine alpha sine of beta. Okay, so I'll do beta first because that's easy. It's in the first quadrant, everything's positive, and sine and cosine of beta are both 1 over square root of 2. Okay, so then 5 pi over 6 is right here. Sine is positive, and sine of pi over 6, just draw my angle real quick, is 1 over 2. So this is 1 over 2. That one's positive, but cosine is negative. And cosine of pi over 6 is square root of 3 over 2. So then just multiply this out. 1 times 1 is 1, minus negative square root of 3 times 1 is negative square root of 3 over 2 square root of 2. So that's our answer for number 18. 1 minus square root of 3. And I guess I could save time by not typing it in, but come on. 2 square root of 2. Okay, 19. Approximate the solutions to the following equation. Okay, so this is tangent of 0.27. So it wants to know all of them. So tangent is positive here and here. So this one will be your angle in the calculator. Like I just got to plug it in. But this one is going to be pi plus whatever I get in the calculator. So remember, make sure your calculator is in radians, right? Yes, answer in radians. So changing my calculator to radians. And tangent inverse of 0.27 is, so my first one is 0.2637. And then I'm going to do pi plus that. So plus pi equals 3.4053. So those should be my two answers. Round to 4 decimal places. 0.2637, comma 3.405. Make sure your calculator is in radians. And the way that I remember is it says it right here on the computer, type your answer in radians. So I knew my calculator had to be in radians. Okay, next one, this is sine of alpha plus beta again. So that's sine and then cosine. And we need a plus sign in the middle. So this one. Okay, so now we got to find out what they are. So we've got 2 pi over 3, that's right here. Okay, so that means sine is positive, but cosine is negative. So sine of pi over 3 is square root of 3 over 2. Cosine has to be negative, and it's 1/2. Okay, and then we got 3 pi over 4, which is also right here. So again, sine will be positive. Sine of 3 pi over 4 is 1 over square root of 2. Cosine will be negative. So negative 1 over square root of 2. So that goes right here. Square root of 3 divided by 2. Negative 1 divided by square root of 2. Negative 1 over 2. And then divided by square root of 2. And then multiply it all out, we get negative square root of 3 minus 1 over 2 square root of 2. Oops. 2 square root of 2. Okay, 21. Oops, sorry guys, couldn't see. Okay, so basically, where does tangent of theta equal 1 over square root of 3? Now remember, tangent has a period of pi, so there's usually just one equation for these, and I'll show you why. Okay, so where does tangent equal 1 over square root of 3? I'm going to scroll back up here because I already have the triangle. So pi over 3. Tangent is opposite over adjacent, so it's a pi over 6 angle. Okay, so scrolling back down, and it's positive. Where's tangent positive? Here and here. So this is pi over 6, and the pi over 6 angle right here is 7 pi over 6. So theta is equal to pi over 6 plus your period, which is pi k. Normally, you would make a second equation, 7 pi over 6 plus your period is pi k. But when you do pi over 6 plus pi, which is the same thing as 6 over 6, you get 7 pi over 6. So I don't need this equation because I can get it using just this one. Okay, so one equation, we've got pi over 6, and then plus pi k right there. But my two answers are pi over 6 and 7 pi over 6. So it's one equation, but still my two answers right here. Okay, hope that makes sense. All right, 22. Okay, cosine squared x, that's cotangent, sorry, minus cosecant squared x over cotangent x plus cosecant x. So the first thing you should do is factor out the top because the top is difference of perfect squares right here. So this is cotangent x plus cosecant x times cotangent x minus, I'm going to scroll back up, cosecant x all over cotangent x plus cosecant x. Okay, so literally the only one that does that is A, but then these two cancel out and then you're left with, they're left with. So answer for that one is A. Okay, 23, cosine of 2 times tangent inverse of 3 pi over 7. So you gotta remember, this is the same thing as an angle. So this is like having 2 times theta. If that makes sense. And then you're gonna come over here and use one of your double angle formulas. There's several for cosine. I'm just gonna use this one is equal to cosine squared theta minus sine squared theta. Okay, so I gotta find out what theta is. This is theta, tangent -1 of 3 over 7. So then draw it in quadrant 1 because it's positive. Okay, so theta is opposite over 7. And then we got 49 plus 9 is 58. So right here is the square root of 58. Okay, so cosine is 7 over the square root of 58 squared minus sine, which is 3 over the square root of 58 squared. So this is going to be 49 over 58 minus 9 over 58, which is equal to 40 over 58, which can be simplified. Those, I guess 4 goes in both of those. Nope, 4 does not go into 58. So let's just do 2. 40 divided by 2 is 20. 58 divided by 2 is 29. I think that's as far as it can be simplified. Oops, sorry. 20 over 29. Okay, 24. Okay, I'm going to do this one more and then I'll have to pause and come back again. I'm sorry, guys, it is taking me a while. Okay, tangent of alpha is that such that alpha is in between pi and 3 pi halves. So that basically just means alpha is in quadrant 3. So determine the value of the half angle. So where does the half angle lie? Remember, to find that, you start with the inequality that they give you. And then we're looking for the half angle, so we're literally dividing everything by 2. So this would be pi halves, my half angle, and 3 pi over 4. Well, remember, pi halves is right here. 3 pi over 4 is right here. So your half angle is somewhere right here. That's quadrant 2. Okay, so tangent is negative in quadrant 2. So you need the negative version, and you can just use your formula sheet. So tangent is -1 minus cosine over 1 plus cosine. So this one. Okay, and they don't tell us what cosine of alpha is, so we gotta find it. So I know that my alpha, remember from up here, is in quadrant 3 because it's in between pi and 3 pi halves. So my alpha is down here, and then I know that tangent of alpha is 12 over 5. So tangent is adjacent, no, sorry, opposite over adjacent. So 12 over 5. And I know that both of these are negative because it's on the negative x and the negative y. Okay, so now we just got to find our hypotenuse, and we'll know what cosine is. So 144 plus 25 is 169, which is a perfect square of 13. So cosine of alpha, which is what we have to use in our formulas, is -5 over 13. So this is what I'm going to be using. Okay, so scroll down and find the formula that matches. So I need a negative in front. So it's going to be b. And cosine of alpha, I'm just plugging it in. -5 over 13 for both. -5 over 13. And that should be it. Make sure it stays clicked on the one that you want to click.